I'm going to talk to you about acoustics in education today in 4 minutes. I find this subject fascinating. I've learned a lot from the previous speakers, and I'm grateful for their presentations. If you're an architect, a designer, if you have children at school or university, or perhaps even grandchildren, you'll find this particularly interesting. Let me start with a fascinating building, an amphitheatre in Greece that I had the opportunity to go and visit and actually do some research at March of last year with Adrian James from Adrian James Acoustics. You may have been to Epidaurus before and know that the phenomenal acoustics take you quite by surprise. In fact, it's one of these places that exceed your expectations. From the sweet spot at the bottom where a speaker may stand, may perform, may speak, you can hear them clearly 60 meters away, and on the speech intelligibility rating, you get a good rating. You can hear them well at that distance. To put that into context, when we measure some government framework schools that have been built recently, we can't get that at 10 to 11 meters from the front to the back of a classroom. That the very clever Greeks were getting 4th century BC. There's no excuse. So we went out to investigate why it works so well, and we'll be producing a paper at International Acoustic Conference in Lyon this year to share the secrets that the Greeks came across. But for you architects, you'll know that Vitruvius actually refurbished this and added a further 28 rows in the 2nd century AD. And he didn't know if they were geniuses, but he copied what they did, and it worked out beautifully. And you get these wonderful acoustics. Why does it work so well? And what can we learn about our learning spaces, our lecture theatres in particular? Part of the reason it works so well is there are no walls and no soffit. If we could reproduce that in all of our spaces, we'd do well. But it's not very practical, is it? Especially in the UK, especially now when it's raining outside, it wouldn't work. So what we need to do is make, as Oliver alluded to, our ceilings and our walls acoustically invisible. So on the left, you can see a very recent lecture theatre. In fact, when the folding acoustic screen goes back, it's one of the largest lecture theatres in the UK, recently created for the University of Newcastle. And in this instance, using rafts, a similar picture to the one that Oliver showed, in fact, we've been able to make the soffit and the walls disappear. And then you get the same wonderful acoustics that you experience at Epidaurus in Greece. Likewise for Kingston, you can see below. So what we're trying to do is just simply make those spaces disappear. We want to get back to the sky, which acts as a Class A absorber. As Oliver pointed out, that's where we're happiest. The Catalyst building is a recent building by the government and Newcastle University together opposite St James's Park. It's the building on the far left. It's a beautiful building by GSS Architects. Again, every space internally, the ceiling acoustically disappears, and the first 2 floors have been carefully designed to be dementia-friendly, particularly important to an increasing and accelerating proportion of our population where acoustics is fundamental to the way they act and respond to a building. On the biophilic theme that Oliver's presented so well, you can bring the outside in. Here we have some acoustic walls. They're our acoustic wall panels that have been screen printed. We can fool the eye and give the same benefit to the brain as though we were outside. You can't tell the difference between the screen printing and a real hedge, a real forest, a real lake scene. When we take students who are kicking off down a corridor to the calming room, and that corridor is lined acoustically with a screen printed panel with a beautiful scene of nature, their heart rate drops and they're already halfway to calming down before they get to the calming room. Fascinating and easy to do. This was shortlisted for the Sterling Prize. Michael-led architects and Riacon Hall, a beautiful building that's changed the skyline of Glasgow. I highly recommend it, and if you'd like to visit, come and see me afterwards. All credit goes to Arup Acoustics, who are up next, because the 2nd largest atrium in the United Kingdom is incorporated into the city campus building, and learning spaces come off of that noisy, busy atrium with a coffee shop, and yet it works. Closing up or screening off all those floors would have been a nightmare for those designing the mechanical ventilation. But through careful acoustic control and modeling in their sound lab and the use of appropriate materials, we were able to make those spaces work and give a 20 dBA reduction from the atrium side into the learning space without having to use walls. And of course, there's a great cost saving that goes with that as well. So we can imitate nature internally. So here's our class. They're very biophilic at the moment. There are 5 fundamental factors for a good learning environment, and they are lighting, as much controlled natural daylighting as possible, ergonomics, air temperature, air quality, and of course acoustics. And if you ask the Department for Education, they will put acoustics at number 2 only, Colin will be pleased to hear, after lighting. I'd like to talk to you about inclusivity. I'd like to talk to you about people with autism in particular and those with hearing impairments. People with autism spectrum disorder vary widely in their abilities, which is why it's called a spectrum. 50% will have an IQ lower than 70 and will have learning disabilities. But conversely on that spectrum, there are very high-functioning people with Asperger's, which you may have heard of. People like Darwin, Mozart, Einstein, Bill Gates, Steve Jobs, and we need to cater and design for their learning spaces. Sometimes they're very high functioning and make very good engineers and architects, and we need them in society, and they've done some remarkable things for us, but we need to support them. 95% of people on that spectrum struggle to process information from several senses at once. They can't do it. Quite often they don't have the filter. They'll hear the dog outside, the car rumble, the pencils being tipped out on the desk, and the teacher 3 feet away from them at exactly the same level. And it drives them insane, and it would for you and I as well. And we need to reduce the sound levels and reduce the reverberance or the echo in those spaces to facilitate good learning. And the most significant influence on that behavior is the acoustics element. Recently, the Institute of Construction Environments reported that with autism, you can triple the amount of time that students can be on focus by simply reducing the ambient noise level and the reverberation time. It's a significant difference, and of course, that affects behavior as well. It's not a nicety. It's not something that we hope to achieve or a guideline. It's statutory. Thank you to Emma Greenland from Anderson Acoustics for this slide. BB93 is something that's close to my heart and I work with regularly. It's part of Building Regulation E4, as are the school premises regulations. The Equalities Act is in there as well. We are obliged to design acoustically well an optimal acoustic environment for everybody, because we now know there is one student with an educational plan for every classroom in the United Kingdom. So why are we working to different standards when the chances are somebody who really needs good acoustics is going to come through that space? Why don't we just be inclusive from the beginning? Architects already know this. There's a fantastic book called The Great Schools Guide, promoted by Hawkins Brown, recently launched by Gratnell's The Planning Learning Spaces, which I had the opportunity to write the acoustics section for, are available and will give you extra guidance on how to do that. I love this. We didn't come up with this. This was an architect called Graham Ogle in Northern Ireland. That learning space has optimal acoustics, great reverberation, low ambient noise levels, created by the biophilic acoustic rafts, which are the leaves. The green leaves are acoustic rafts. The children love to sit on that seat at the bottom and will get all the benefit as though they were outside sitting underneath a tree with great acoustics and the feeling of being back to nature. When there are 13% of our students who require this, again, ought we not to be refurbishing and designing to accommodate them? It does make a difference. The Essex study, which led up to the change in BB93 to be more inclusive, led to a refurbishment of the entire school so that everybody had optimal acoustics, including the Department for Hearing Impaired and Autistic Children, of which there were over 30. This is the difference that it's made.
Hi, my name is Sarah and I'm in Year 12. I go to Swain Park Sixth Form as I started Swain Park in Year 7. For my GCSEs, I've studied triple science, psychology, history and French. Currently I'm studying biology, psychology and philosophy in A-levels. My hearing impairment is that I am profoundly deaf, and 2 years ago I started having hearing difficulties, so I had a cochlear implant operation. Now I wear 2 cochlear implants. My feelings about this school is that I am feeling much happier this year, and I feel part of the community. Also, in some classrooms, the sound absorbance helps me as it's less distracting. Also, I can sit anywhere in the classroom, not always at the front. Also, I feel much happier and I feel part of the community and more involved in group work. In the future, I would like to study physiotherapy in university. Also, I would like to say a message towards the audience. This has made a difference to me. Can you go and make a difference to others?
Thank you.